Hello everyone, right now I'd like to explain to you permutations and combinations, that is, take the pain out of the explanation of it. Most students struggle with this. In fact, if this makes you nervous, seeing these symbols, then you're in the right place. One thing you can do straight away to make them more friendly is do this, a little smiley face, or sticking their tongue out, and that already helps a little bit, okay, but it won't last too long. In the meantime, we need to actually get a handle on what these mean. But don't worry, just give me 5 minutes. Okay, so first I would like you to consider the problem of choosing socks. So here we've got some of my daughter's socks, 5 different ones. They're nice and little, that's why I picked them. Also, my socks are just black. Okay, so we have 5 different socks, and let's say they're in a box, and I want to choose them for her to wear in the morning. And I look in the box, I grab into the box without looking, which happens as you're busy with other things, trying to do 5 things at once. So first I pick sock number 1, and how many choices do I have for picking? I have 5 choices, yeah? Okay, so let's pretend that I pick this one. Alright, that's fine. So that one's picked. Now I have how many more to choose from? So for sock number 2, I have 4 choices to pick from. So let's say I pick this one without prejudice. Okay, so my total number of choices for picking 2 socks out of 5 are 20. Okay, 5 times 4. So 5 choices for the first sock, 4 choices for the second sock. Okay, so that gives me 20 different permutations, as it were. Okay, that gives me dark pink, light pink, or was it light pink, dark pink? I don't remember which order I pulled them in, and actually really it doesn't matter, does it? And that is a point I would like to make right here. The order in this particular case doesn't really matter, unless you care what my daughter wears on her left foot versus her right foot, or vice versa. But to me that's pretty much the same, they're mismatched. So that's the problem. So actually the order doesn't matter. Whether I pick pink first or I pick dark pink first is the same thing to me. Okay, so unfortunately I've got too many right in here than I really care about. So 20 different combos, but that includes light pink, dark pink, light pink. Okay, so really what I'm going to do is I'm going to slash these in half, because I want to collapse those 2 categories. I want to say, yeah, that doesn't really matter, the order among them. Yeah, so if I have, these are very alike, if I have these socks, if I pick them in this order, first this sock and then that sock, or first that sock and then this sock, to me that's the same. But unfortunately, without this division, that they will be listed as separate cases. Yeah, 5 choices for the first one, 4 choices for the second one. So I'm going to divide out the combinations among them. There are 2 ways to put these together, this or that. So I'm going to divide those out, okay? And so it'll be 10 in the end, is going to give me the combinations, 10 combos. If I divide by this 2, like I did, I will have combinations. So I would write this 5 choose 2. So I have 5 to choose from, and I choose 2 out of them, or 5 combinations of, well, 2 combinations out of 5. So it's written 5 choose 2, or an even easier way to write it, because mathematicians are lazy in writing, is this 5 choose 2. It's just another way of writing it. This, I don't know why it's on top of each other with brackets, looks more like a vector to me, but I guess it is in a sense. Anyway, so that's it. If I don't do that too, so if I just do 5 times 4, which is 20, that's the permutations. So that is written 5p2. So how many ways are there to permute 2 socks from among 5? Here the order does matter. So here this is different from that. Okay, that's why there are twice as many options there. Okay, one good example for this is runners in a race. When you're running in a race, you care about whether you're first, second, or third, right? So, how many ways of choosing top 3 runners among 10? Okay, so first you have 10 choices for the winner, number 1 winner. Then you have 9 choices for the second, so the first runner-up. And then you have 8 choices, or 8 possibilities, for the the second runner-up or the third place. Okay, and here the order does matter. So who is first, who is second, who is third, very much matters. So that would be 10 permutation 3. Okay, so 10p3. We have this many permutations. What is that? 9 times 8 is 72, and so times 10, 720. So there are 720 ways that the race could end up with 10 runners. Okay, so this is where the order does matter, and I use permutations because let's say if the race winners are Charlie, Joe, and Bob, that's different from Bob, Charlie, Joe, or Bob, Joe, Charlie. They will care who's first. Okay, so that's where we're not going to divide out the combinations of winners. Okay, but let's say you have 3 winners in a prize draw. Hopefully you can read my writing. So let's say you have 10 okay, from among 10 people. Among 10 people. So let's say you get 10 people and you say 3 of you are going to win a prize, $100. And just 3 prizes, it's the same. So here we're going to have 3 choices. So first you pick your first winner. You have 10 ways to do that, or 10 options. Then the second winner, you only have 9 people to pick from because one's already won and gotten the $100, okay? And then for the third winner, but really the third equal because they all get $100, you have 8 choices, yeah? Okay, so let's say you pick Joanna, Louise, and Susie from among 10 people. Does it really matter whether you pick Joanna first, then Louise, and then Susie, or Susie, Louise, Joanna, or Louise, Susie, Joanna, or whatever? It doesn't really matter because they each get $100, so they're happy. Louise doesn't care if you draw her first as long as you still draw her second. As long as she's still drawn, it still gets $100. Does that make sense? So we actually don't have that many choices. We don't have 720 ways because Louise, Joanna, Susie, and Susie, Joanna, Louise, or whatever, is the same thing. So we're going to divide out all the ways that you can combine 3 winners. How many ways can you combine 3 winners? So how many combinations are there, you know? Louise, Susie, Joanna, Joanna, Susie, Louise, blah, 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 etc. Well, how do you order 3 people? Order 3 people. You have 3 choices to slot a person into number 1. Then 2 choices for the second one when you're ordering them. And then 1 choice, really no choice, which is what we call it in the real world, but in maths we would say 1 choice, I suppose. So 3 times 2 times 1. So there are 6 ways of ordering that. So really we only have a 1/6 of the number of options we thought because, like I said, Louise, Susie, Joanna, Joanna, Susie, Louise, that's all one to us. We're not going to list those as separate outcomes, but that's the same outcome. These same 3 girls are very happy that they got $100, yeah? So we divide that by 6. Okay, and what is that? 12, I guess? 120? Okay. Alright, so this would be 10, choose 3, or combinations, not permutations. So in permutations the order matters, which order you draw them in. So among the three chosen ones, the order matters. ABC is not CBA or BAC. In combinations, the order doesn't matter. So ABC, CBA, BAC, or Louise, Joanna, Susie, Susie, Joanna, Louise is all the same thing. We don't care about the order. Okay, so that's where you use combinations. Whereas if the order does matter, you use permutations. Okay, because we're not dividing out those duplicates. Now, as the last thing, now that that's hopefully clear, I'm just going to talk about notation. Because I wrote things very easily, but if you have large numbers, say if you're picking 30 from 100, you don't want to write out 100 times 99 times 98 times 97, you know, the first 30. You don't want to do that. There's got to be fast ways to do it, and there are. So just spend a couple minutes on notation. Do you know what a factorial is? If you don't, 7 factorial, I hope you don't mind, I'm going to do a European 7, because otherwise sort of looks like a 1 or other symbols. 7 factorial is just a way of writing, a short way of writing 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, that's kind of unnecessary, eh? Don't really need that. Times 1 doesn't do anything. Okay, so what say that if I had 7 factorial over 4 factorial, what would that be? That would be 7 times 6 times 5 times 4 times 3 times 2. I'll leave away the times 1. And that is 4 times 3 times 2 times 1. Unnecessary. Okay, now here we can cancel. It's all times and division, no plus or minus. You're allowed to cancel. So the 2's cancel each other. And what is left? 7 times 6 times 5. So this is counting down from 7. 7, 6, 5, 4, 3, 2. All multiplied. This is counting down from 4. And anything from 4 and downwards cancel. So really, this kind of chops off the tail of this countdown. Okay, so this countdown gets its tail chopped off by this factorial. Fancier word is to truncate, so to cut off. So this truncates. So if I want to write my combos from up here, I could have also written for this, now where do I put that? Here maybe. I could have written 5 factorial over 3 factorial. That's just to take care of the 5 times 4. Okay, so forget about the 2 for now. So 5 times 4, that would be the same, because this is 5, 4, 3, 2, 1. This is 3, 2, 1. The 3 2 1's cancel, and all that survives is 5 times 4. If we also have this 2, this is how many times you can combine 2 socks, which is just 2 times. I put that here. This is really 2 factorial, but I'll get to that in a second. Just leave it for now. Okay. Whereas here, the permutations, I would just say there is 5 factorial over 3 factorial. Okay, just 5 times 4. So this is a fast way of writing 5 times 4. Seems unnecessary for these numbers. Yeah, it is, but imagine again if you had 100 choose 30. And you'd have to do 100 times 99, 98, 97, the first 30. It'd be much easier to go 100 factorial over 70 factorial. Okay, so which cuts off all but the first 30. Okay, so here, in a little bit further down, we could write it like so. We could say, well, that is 10 factorial over 7 factorial. Why 7? Why not 3? Well, I only want the first 3 to survive, okay? Because I choose 3 runners. So 10 choices, 9 choices, 8 choices for the top 3 runners. So I want everything from 7 down to disappear. So it's only 10, 9, 8 left. So that's why 7 factorial, okay? So if you wanted a formula for permutations, you could say NPK. So N permutations K. Then this is how you would write it. You would say that's n factorial. That's the total number of choices or things you can choose from. And this is n minus k, which cuts off the tail and leaves only the first k, right? So the first k are fine, but then anything on down from there is cut off. Hopefully that makes sense. So just think of these numbers. 10, and you want 3 to survive, so you need to cut 7 off. Why 7 was 10 minus 3. Okay. And with combinations, here if you have n choose 3, with these you would say that's 10 that you're choosing from, 10 factorial, but you want to cut off 7, so it'd be 10 minus 3 factorial, in brackets please, because we don't want to subtract 3 factorial from 10. But then we've also got to take out all the ways that we can combine the 3, yeah, because the top 3 actually don't matter in order. They're all 3 winners of equal prizes. So we're gonna write here how many ways there are to order 3 items as 3 factorial. Yeah, and for the sake of a formula, that's why I said this is actually 2 factorial, which is 2. 2 times 1, so it's 2. Okay, and so as a sorry, this is kind of in the way. So as a general rule, you would say that's n factorial over n minus k factorial, but then you have to take out the multiples, which we don't care about, and that is k factorial. So how many ways can you order the top 3 people, because the order doesn't actually matter. So these are the 2 formulas that you have. So for npk, for permutations, it is n factorial over n minus k factorial. The order of the chosen ones does matter, and for n choose 3 or combinations, that's not 3, sorry, k. Why didn't anybody tell me? Okay, for n combinations of k, we have n factorial over n minus k factorial. That's just the first k items, and the tail gets cut off. And this, we have to take out the multiples because the order of the chosen ones doesn't matter. Okay, so hopefully that is helpful. And you see now my problems of choosing socks every morning, which has prompted this, which is why I just went to the shop and got a whole lot of pink socks, and that removes the whole problem altogether.